Okay, so what we're going to look at next is confidence intervals. So we're kind of continuing the trend of looking at the all the really important leaving cert specific stuff, I suppose. So confidence intervals and population proportion and all of these things are very, very high, very, very related. So we'll get into kind of what we're looking to make an interval for first. And this is what we call our population proportion. So a proportion is, I suppose, a fraction or a percentage of a group. That's like a proportion of something is kind of a fraction of something or a percentage of something, a kind of measure of part of something. So population proportion is the proportion of the population who have a certain characteristic or who answer a question a certain way or who intend to do something that we're investigating. So for example, if I was investigating how many Leaving Cert students will study medicine, then the population proportion is how many Leaving Cert students are going to study medicine out of all Leaving Cert students. Or how many people are going to vote for a certain party, then it's how many people are going to vote for a party over the total number of people who will vote, full stop. Now, the thing with population proportion is, as much as we would like to know it, like all of these political parties would love to know how many people are going to vote for them, it is very hard, near impossible, I suppose, to confidently say how many people are going to vote for you without obviously the votes happening, of course, is one way of doing it, but that can only happen because that is run, that is financed. There's multiple people working on it. It's a huge operation. Whereas me specifically setting out to do it, I'm not going to be able to do that. So therefore, what I would probably do is ask a smaller group of people or a number of smaller groups, and from that, I would make conclusions. I would kind of generalize, and I would hope that I'm able to give an estimate for the real value. I'm never going to be able to get the exact real value, but I might be able to give some sort of estimate of that. And what I would be doing there is finding what we call the sample proportion, and we use p hat. So what that is I look at my sample and I say, okay, how many people in this sample does this apply to out of my sample? And then rather than just saying, okay, that's true, that's it, I'm going to say, yeah, in the sample it was 40%, so it's 40% for everyone, and the actual thing is 40%. I'm going to say, okay, there's a chance that I've gone slightly off here, that I've got an answer that could be incorrect or that I might need to adjust somehow. So what I would do is I would introduce, or I would look for, a margin of error. And what a margin of error is it's an allowance, I suppose, for the potential for error. The fact that a sample is not always accurate, there's potential bias. If it's small, that can obviously lead to some inaccuracy. So what we do is we take our margin of error, and we are going to use the margin of error approximation, is really what it's called, which is 1 over the square root of n. Now this is really important, and this is not something that is given to you, so this is something that you would need to learn off. Okay, and it's going to be really important for all these questions. So really what we're doing is whatever the sample size is that we take, we're doing 1 over the square root of that sample size. And that is going to give us some measure of error that we're going to have to allow for our questions. So we're going to still work out what our sample one is, but we're also going to say, okay, but there is still a chance that we have made a mistake here or that we've got some sort of error, so we will account for that as well. So rather than committing to one answer, we're going to give ourselves a bit more of a range. Now focusing specifically on margin of error, to calculate margin of error is fairly simple. 1 over the square root of n, so whatever your sample size is. So for the first one here, it's 150. So 1 over the square root of 150. And for most of these, we're going to convert it to a percentage. So let's just multiply that by 100 to get 8.16%. So for a sample of 150 people, I would need to allow myself a margin of error of 8%. Okay, so that's my margin of error here. If we want an error of approximately 2%, then 2% is the same as 0.02. So I want my 1 over root n to be 0.02, or to give me an answer of 0.02. If I square both sides here, I get 1 over n is 1 over 2,500, which should mean that n is 2,500. So to get a margin of error of 2%, I need to have 2,500 people. The reason both of these are important is that we use these in constructing confidence intervals. And this is really what I've been getting at, is that idea that I'm going to go out and I'm going to ask a sample of people, a group of people, okay, what do you think? Who are you voting for? Okay, let's just go with that one. So who are you voting for? I ask a group of people, are you going to vote for this party? And some of them say yes, and some of them say no. And I say, okay, grand. Out of my sample, 20 people have said yes, and that's 20 out of 100 people. So therefore, 20% of the country is going to vote for that party. And obviously, we know that's not the case. Okay, it's going to hugely depend on the people that I ask. So rather than just committing to that 20%, I go, okay, I asked 100 people, so I need to allow for some margin of error here. So for 100 people, that would be 10%. So I need to allow myself a margin of error of about 10%. So either side of the actual value there, I have to give myself a room or wiggle room there of about 10%. So I would really be saying, right, I know my sample said 20%, but really I probably need to go anywhere from 10% to 30%. And I'd be fairly confident that the real value's in there. Based on my work with my sample and me allowing for some margin of error, that should lead to me being fairly confident that the true value is somewhere within there. And what we actually get with these is, with these intervals, if we set it up in that way, if we do all of that correctly, get our proportion correctly, allow for that margin of error, we actually end up with an answer that we can be 95% confident of. So it's 95% confidence. So if we can set all of this up correctly, we can come up with an answer that we are 95% confident of. And that's hugely beneficial for us when we're trying to kind of make inferences or kind of suggest conclusions to data. So let's kind of get into some examples and some of the questions on this for our confidence intervals. So looking at the first one, in a survey of 2,025 people, 500 said they enjoy pineapple pizza. Construct a 95% confidence interval. So there are three parts we'll look at, or three parts that we look at for our confidence interval. The first is the margin of error. To get margin of error is 1 over the square root of n, and n is the sample size. So in this one, this is 2,025 people. So let's fill that in. So my margin of error here, and I'm also going to multiply that by 100 to get it as a percentage. So that is going to be 2.2%. The next thing I'm going to look for is the sample proportion, and the sample proportion is called p hat. That is the proportion or fraction of people in the sample who answered the question in the way I want. So I'm maybe looking here at how many people enjoy pineapple pizza. 500 people do out of the 2,025 people that I asked. And again, I'll make that into a percentage also. So that's going to be 24.7%. Now what we want to do is we want to do our confidence interval. And remember that we are 95% confident of our answer that we're going to get here. The way that we will construct our confidence interval is fairly straightforward. We are going to start with the answer that we got from our sample, and we are going to allow ourselves that room for error. So we're going to add and subtract that number. So starting with 24.7%, I'm going to take away 2.2%, and I'm going to add 2.2%. So that gives me 22.5% and 26.9%. So what we're saying here is we don't necessarily believe that 24.7% is the exact 100% right answer, but we are 95% confident that the real answer is between 22.5% and 26.9%. That's what we're saying. So based on the work that we've done, we are 95% confident that the true value is somewhere within that range. So we're giving ourselves a bit more wiggle room, and obviously the more people we ask, the smaller that margin of error would be. So if I can ask more people, I can be more accurate. So let's look at some of the exam questions then under this heading as well with our confidence intervals. So a few days before Scottish independence referendum, a YouGov poll estimated the support for the No campaign was 54%. If YouGov sampled 1,000 people, find the margin of error. So remind ourselves, margin of error is 1 over the square root of n. In this case, that is 1 over the square root of 1,000. And they've asked us to give us a percentage, so I'm going to then multiply that by 100. So let's just calculate what that answer is going to be. It's going to be 3.1623%. They said as a percentage to one decimal place, so 3.2% here as our margin of error. So we are allowing ourselves a margin of error of 3.2%. So whatever value we get, we are going to allow ourselves a bit of wiggle room of about 3% either side of that answer. So we're asked to make a 95% confidence interval. So we know from the last time, the first thing I need is margin of error, which I have. The second thing I need is sample proportion. That is the proportion of the people in the sample who agree with whatever the situation was. Now in this question, the sample that they took, the proportion of people who did agree was 54%, who said they were going to vote no. So this proportion of people I'm considering is 54% here. To construct my confidence interval, I'm going to start with my 54%, but I'm going to say, okay, there's a margin of error of 3.2% here. So really the true value could be up to 3% below that. But equally, it could be up to 3% above that. So I need to go both directions. So that's going to bring me down to 50.8% and 57.2%. What we say now is I am 95% confident that the true proportion of people who intended to vote no for the campaign is between 50.8% and 57.2%, which is a much wider range than that 54 that we got from our sample there. So we're definitely allowing ourselves a good range, a good kind of margin for error there. Let's do one more example. Find the margin of error associated with a survey of 1,276 people. Give your answer correct to 3 decimal places. So let's start first of all. Margin of error, we already know, is 1 over root n. So that is 1 over the square root of 1276. So calculating what that would be as a percentage, I'll multiply it by 100 as well. That's going to be 2.799%. 2.799%. Let's look at another example, or the next part, I suppose. In a particular survey, 1,276 people were selected. Of those, 740 said they were satisfied with the level of public transport in their area. Create a 95% confidence interval. So we need to start here with our sample proportion. This is the proportion of people in this sample, in this survey, who were in line with what we were investigating, which was 740 out of the 1,276 people. Let's calculate that as a percentage also. So that is going to be 57.994%. To get my confidence interval then, we are going to start with that value, the 57.994%, and we are going to subtract the margin of error, which was 2.799. We are then going to go back to our 57.994, and we're going to add the margin of error, which is our 2.799. So going in both directions there, allowing ourselves that bit of wiggle room either side, just that room for error. So we have to allow ourselves error so that we're able to be confident and that we're able to be accurate. So the more confident we want to be, we have to still allow ourselves that room for error there. Part 3 then says what change could be made to decrease the margin of error. So think about the margin of error is the 1 over root n. So to decrease that, we need to increase the sample. So if I ask more people, I will be more accurate. So increase the sample size or survey more people. If I do those things, that's going to make my sample more accurate. That's going to make the margin of error smaller. I'm still going to go with an interval. And I suppose that's a key part of this as well, is we're always making a confidence interval. I'm never trying to work out, well, what do I think the value is? I'm always going, well, here's a range within which I think the value would be, because there's always that room for error. But to make that error as small as possible, you ask as many people as you possibly can. So the key things so far with this are making sure you're able to calculate the margin of error with your 1 over root n, and then making sure that you can do your confidence interval using your p-hat, your sample proportion. If we're able to do both of those, that's going to, I suppose, help us with these questions, but also set us up really well for the questions to come with our hypothesis tests.